What if the first undeniable proof of life beyond Earth didn't come from a faraway galaxy, but from the star system next door? Just imagine. A rocky world orbiting Proxima Centauri, the closest star to our Sun, might hold the answer to one of humanity's oldest questions: are we alone in the universe? Recently, the James Webb Space Telescope made an observation so unexpected that it sent shockwaves through the entire scientific community. What it captured, nearly 7 trillion miles from Earth, has sparked one of the most fascinating debates in modern astronomy. Across the dark face of Proxima Centauri b, a faint, rhythmic glow was detected, patterns of light that look strikingly similar to the way city lights shine on Earth at night. Could it be? Is it possible that an alien civilization, orbiting the nearest star to our solar system, is using artificial illumination, much like us? A mysterious neighbor. Proxima Centauri lies just 4.25 light-years away, making it our closest known stellar neighbor and a key target in the search for life beyond Earth. For years, scientists have studied its planet, Proxima Centauri b, since it sits within the star's habitable zone, the region where liquid water might exist. But this world is no paradise. It orbits its small red dwarf star at a blistering distance of only 4.6 million miles, meaning it's constantly bombarded by solar flares and radiation. Such conditions could easily strip away any atmosphere, making life there seem unlikely, until now. The strange light signatures detected by JWST have reopened the question. Could these glows truly be technological in nature? Or are they the result of some unknown natural process we have yet to understand? A telescope beyond imagination, the James Webb Space Telescope is the most powerful observatory ever built. Its infrared vision can detect even the faintest traces of heat and light across vast cosmic distances. This is what allowed it to spot those unusual patterns on Proxima Centauri b's night side. Infrared imaging doesn't just reveal brightness, it uncovers temperature differences, heat emissions, and even chemical compositions. By analyzing how light interacts with the planet's atmosphere, JWST can identify gases like oxygen, methane, and water vapor, molecules that often hint at biological or even technological activity. If the glow truly comes from artificial sources, it would mean that something, or someone, is actively generating energy on that world. Surviving on Proxima Centauri b would be unlike anything we know on Earth. Orbiting dangerously close to its parent star, a volatile red dwarf, the planet endures a constant barrage of intense solar radiation and violent stellar flares. These flares, sometimes hundreds of times stronger than those from our own Sun, could instantly strip away atmospheres, scorch surfaces, and turn oceans into vapor. Yet, the James Webb Space Telescope's infrared observations suggest that something extraordinary may be happening there. If the planet truly emits light from its night side, steady, patterned, and consistent, it hints at activity far beyond natural geological processes. How could anything, or anyone, survive in such conditions? Scientists believe that if life does exist on Proxima Centauri b, it must be technologically advanced, capable of engineering survival itself. Imagine a civilization that has evolved or migrated beneath the planet's surface, building vast underground cities shielded from the deadly flares above. Perhaps they draw energy directly from the planet's magnetic core, or harvest the faint light of their red sun through quantum solar systems buried deep within the crust. Other theories go even further. What if the civilization on Proxima Centauri b has learned to manipulate light and heat themselves, not merely to survive, but to declare, "We exist"? The faint glows captured by the James Webb Space Telescope could be more than coincidence. They might be energy domes stretching for miles, thermal grids woven into the crust, or vast biotechnological ecosystems that pulse with synthetic light, entire cities glowing gently under a dark crimson sky. To imagine that is to accept a stunning possibility. Somewhere beyond the reach of our Sun, intelligence may have conquered its own apocalypse, learning to thrive beneath the fury of a star that should have destroyed it long ago. Dr. David Kipping, an astrophysicist at Columbia University, has long argued that Proxima Centauri b's thermal patterns are unlike anything ever recorded. Most rocky planets absorb sunlight, release heat, and cool with the onset of night. Yet Proxima b refuses to follow that rule. Its warmth lingers long after darkness falls, as though the planet itself is governed by a hidden thermostat, a rhythm of energy that appears too ordered to be natural. Kipping calls it anomalous heat retention. Others quietly call it technology. If the readings are accurate, they point to a self-sustaining power source, perhaps fusion grids, geothermal reactors, or something beyond human comprehension. And if that is true, it redefines what we believe life can be. Because it means that life, when confronted with extinction, does not surrender, it adapts, transforms, and rewrites its own destiny. Proxima Centauri b could stand as the ultimate symbol of resilience, proof that intelligence is not fragile or rare, it is inevitable. A new era of discovery. This revelation marks the dawn of a new chapter in astronomy, a time when scientists search not just for oceans and forests, but for technological fingerprints scattered across the stars. The James Webb Space Telescope is only the first messenger of that new age. Its golden mirrors catch light that has traveled trillions of miles, converting cosmic whispers into data lines that challenge every assumption we hold about the universe. But Webb is not alone. On the horizon rises the extremely large telescope, soon to stand beneath the skies of Chile's Atacama Desert. With a mirror nearly 40 meters wide, it will be able to directly image exoplanets, to separate the light of a planet from the glare of its star, and to reveal weather patterns, continents, and even seasonal changes. For the first time, humanity will look upon alien worlds not as distant dots, but as living, breathing spheres of possibility. And beyond that awaits LUVOIR, NASA's ambitious mission to study entire planetary systems in ultraviolet, visible, and infrared light. LUVOIR could detect gases never before seen outside Earth, methane, oxygen, or even industrial pollutants, the chemical scars of technology. Should it find such traces, we would know that civilization is not unique to us. It is a cosmic phenomenon, emerging whenever the universe gives matter enough time to think. Yet, amid the data and the mathematics, a deeper question lingers, one that no telescope can answer. Could those faint, rhythmic lights truly belong to cities? Could they be the glow of another species that has already looked toward our tiny blue world, wondering if someone was looking back? Picture it. On the shadowed side of Proxima Centauri b, under a dim red horizon, a being stands within the shimmering glow of its home. Above them, the night sky burns with countless stars, one of which is our sun, shining faintly across the void. Perhaps they gaze at it as we gaze at them, both civilizations separated by 4 light years, 4 billion years of evolution, and yet connected by the same unending curiosity, the same yearning to understand existence itself. If these lights are real, if they are more than illusion or artifact, then the universe is no longer silent. It means that we are part of something greater, a vast network of minds that have each looked up and asked the same question, in 1,000 languages, beneath 1,000 skies, are we alone? And maybe, just maybe, the answer has already begun to shine back at us.